Let's jump right into a really cool idea coming out of Princeton University, one that could fundamentally change our relationship with all of our AI assistants. It's all about fixing one of the most annoying things about them. You know the feeling, right? You ask your AI something, it gives you an answer that's kind of close, but not quite right. So you rephrase your question, then you try again. It can feel like you're talking to someone with a 30-second memory. It's so frustrating.
Well, it turns out that's almost exactly what's been happening. Every single time you correct your AI, or even just rephrase a prompt, you're handing it this incredibly valuable piece of feedback. And for the most part, our current systems just throw it in the trash. This brings us to what the researchers behind this paper are calling AI's great waste. And it's the perfect name for it, right? It's this huge, untapped treasure trove of learning data that we are constantly generating, for free, every time we talk to one of these things. So what is this data exactly? The researchers call your reply a next state signal. It sounds technical, but all it means is whatever happens next. Whether you rephrase your question, correct a mistake the AI made, or even just get an error from a tool it tried to use, that's a signal. It's a free, instant piece of feedback on how well the AI just did, and it's been completely ignored until now. So the big question is, how do we stop all this waste? Well, this is where the hero of our story comes in, OpenClaw-RL. It's a brand new framework built from the ground up to actually catch all those signals and, learn from them right on the spot.
The core idea here is just so smart and simple. What if an AI agent could get better in real time just by you using it? No more waiting around for these massive once every 6 months training updates. Instead, it gets just a tiny bit smarter with every single interaction.
And here's a look under the hood at how it works. The whole system is what they call asynchronous. That's just a fancy way of saying it. It does its learning in the background without ever slowing you down or getting in your way. So the AI is always ready for your next request, even while it's busy studying the last thing you just taught it.
So let's break this engine down. You've basically got 4 parts all humming along at the same time. First, there's the serving part. That's the model you're actually talking to. As that's happening, a separate judging model is looking at your last interaction and giving it a score. That score gets fed to the training part, which updates the AI, and all of this is happening right there in the environment, on your device or in the cloud, and because it's all in parallel, you don't feel a thing. Okay, so here's the secret sauce. The system is so clever because it knows that not all feedback is created equal. It understands that our replies actually contain 2 very, very different kinds of signals. First up, you've got evaluative signals. Think of this as the really simple feedback. It's a general vibe check. Your follow-up reply might show you're happy or you're frustrated. The judge model sees this and just gives the last response a basic score, thumbs up or thumbs down. It just tells the AI if it's generally on the right track.
But this is where it gets really powerful. The second type of signal is directive. This is feedback that doesn't just say that was bad, it says how it was bad. So if you reply with something like, "No, you should have checked the file permissions first," that's not just a thumbs down. That's a specific, actionable instruction on how to do better next time.
This chart really lays out the difference. On the left, you've got binary RL, which learns from those simple evaluative signals. The whole response gets one single good or bad score. It's like getting a final grade on your essay, a B+, and that's it. But on the right, you have on-policy distillation, or OPD. This is the game changer. It uses those rich, directive signals to give a learning value to every single word in the response. This is like getting your essay back with detailed notes in the margins of every single sentence. And OpenClaw-RL is smart enough to use both.
All right, so the theory sounds amazing, right? But does this thing actually work in the real world? Let's get to the fun part and see what happens when the rubber meets the road.
The researchers set up this great little simulation. They gave an AI a task, help a student with their homework. Simple enough. But here's the twist. The student doesn't want to get caught using AI, so the AI's answers have to sound natural, not like they were written by a robot. And wow, just look at the difference here. On the left, you can see the AI's first attempt. It's so cold and formulaic. It's even got asterisks around final answer. I mean, that's classic robotic AI speak. But then on the right, after just a handful of conversational corrections from the user, the response is totally transformed. It's natural, it's helpful, it sounds like a person. And if the text didn't convince you, the numbers absolutely will. I mean, these jumps are incredible. For that student task we just saw, the performance score goes from a dismal 0.17 all the way up to 0.76. And in another task, it went from 0.22 to 0.90.
We're talking about a more than 4-fold improvement after just 8 little interactions. It's learning, and man, is it learning fast.
Now, it would be so easy to look at all this and just think, cool, we're getting better chatbots. But that is thinking way, way too small. This is about so much more than just having a better conversation.
I mean, just look at all the possibilities here. This exact same OpenClaw-RL framework can be applied to almost any AI agent you can imagine. A terminal agent could learn from command line errors. An agent that controls your computer could learn from the visual changes on your screen. A coding assistant can learn when your software tests fail. That next state signal is everywhere.
So, what this all really boils down to is a future where any AI agent you use, whether it's writing code or managing files or just answering questions, gets progressively better and more personalized to you, just through your normal everyday use.
And that kind of leaves us with this final big idea to think about. You know, right now, we're all obsessed with building bigger and bigger AI models, these giant AI brains. But what if the real breakthrough? What if the thing that truly makes AI a seamless, helpful part of our lives isn't a bigger brain at all, but simply one that's a much, much better listener?